Picture an agent that reads your screen, writes code, and chains together several steps to finish a task, all running on the graphics card already sitting inside your desktop. No cloud call, no data leaving the machine. That is the pitch behind Muse Glimmer, a 30 billion parameter model meta released in August of 2026 under an open Apache license. It is built to act, not just chat, handling tool use and multi-step work across text and images while your personal data stays put. Let us unpack how it actually pulls that off. First, let us see why running an agent locally is such a different bet from the usual cloud setup. Most capable agents today run in the cloud. Your prompt, your screenshots, and whatever documents you hand them travel off your machine to someone else's servers, get processed there, and the answer comes back. That works, but every single request means your data leaves the building. For private files or regulated work, that round trip to a remote data center is often exactly the problem you are trying to avoid. Muse Glimmer flips that arrangement around. It is small enough to run entirely on one consumer GPU with 24 gigabytes of memory, or even an Apple Mac with no network call required. The prompt, the reasoning, and the tool calls all happen locally, so your data simply stays on the device. You trade some raw scale for privacy and control that you genuinely own. So how does a task actually move through Muse Glimmer when everything runs on your own hardware? Follow it one step at a time. This starts when you type a request, maybe pointing at a screenshot or a chart already open on your screen. The model takes it in through a dedicated perception encoder, which reportedly handles up to 4,096 visual tokens per image, right alongside your text. Everything it reads stays in memory on your own hardware, never uploaded, because there is simply no server on the other end. Once the request is understood, the model reasons about how to tackle it. With a context window past 130,000 tokens, it can hold long documents and a running plan at the same time. This is the multi-step part, where it breaks a goal into an ordered sequence of actions before it ever touches a single tool. Here the agent calls the tools it needs, using schema-based function calling to fill in structured arguments correctly. It might run code, query a file, or drive a desktop app by reading what is on the screen. On the MCP Atlas benchmark, it reportedly scores 75.5, ahead of comparable open models sitting at this same size. Finally, the model acts on those results and either returns an answer or loops back for another round. Can write and edit real code, and on the SWE Bench Pro test it reportedly lands around 51. That whole loop, reading, planning, calling, and acting, runs on your machine, so nothing about the task ever leaves your control. Strip it back, and 3 ideas define Muse Glimmer. This model was designed to live directly on your hardware. Full precision reportedly needs about 55 gigabytes, but compressed to roughly 4-bit it fits a 24 gigabyte card with only about 1% quality loss. On an RTX 5090, that compression is said to lift throughput from around 75 to over 230 tokens per second. Beyond simple chatting, it is built to do things. It reads both text and images, powers desktop and coding agents, and handles document and chart understanding. Meta reportedly distilled it from a larger model called Muse Spark, keeping the agentic skills while shrinking the footprint enough to run without a data center standing behind it. The weights ship under Apache 2.0 so you can download, inspect, fine-tune, and deploy them freely even commercially. Paired with local execution, that openness means no vendor lock-in and no data leaving your machine. You end up owning the model, the hardware, and every byte of the conversation itself. Alright, let us lock in the essentials. Muse Glimmer is Meta's 30 billion parameter, Apache licensed model, built to run agentic tasks locally on a single consumer GPU. It reads text and images and acts through tool use, coding, and multi-step reasoning, all while keeping your data on the device. Distilled from Muse Spark, it fits a 24 GB card at 4-bit precision and reportedly leads similar open models on agentic benchmarks like MCP Atlas. Remember, the real shift here is where the work happens on your machine instead of someone else's cloud, trading a little scale for privacy you fully control. If watching AI get demystified like this is your speed, there is a whole library of it waiting over at Standarity.com. Swing by.